All right, guys, so let's go ahead and go over this Leetcode question. So I'm given a string called word, and I want to return the sum of the number of vowels in every substring of word. So a substring is like a continuous sequence of characters within a string. And due to large constraints, the answer might be large. I'm going to code it in Python, so hopefully that doesn't matter. Okay, and some constraints. The length of word is between 1 and 10 to the power of 5, and it only has English letters. All right, so let's go ahead and look at this first test case right here, ABBA. So here are the possible substrings. So I have A, so like I have this. I have AB. I have ABA. I have B. I have BA. I have A itself. Okay, and we got to count the number of vowels in each of these substrings. So for example, like this substring B, it doesn't have any vowels in it. All of these have a single A as the vowel in them, and ABBA has 2 vowels in it. Okay, so we just add up all those counts, 0, and then I have 3 with 1, so 1. No, I have 4 with 1, so I have 4 ones, and then I have a 2, so my answer is 6. All right, so this test case is, yeah, these are kind of like similar. I'll make another test case. So let's go ahead and consider the test case Leetcode. So again, like I can look at every single substring, right? And I can count out how many vowels are within those substrings. But if we look at our constraints, our constraint is 10 to the 5th. So that means that like, in our worst case, we should be getting like an O of n log n solution, maybe an O of n to the power of 3/2 solution. But again, we can't look at every single substring because that would be like, okay, so like if the length of the word is n, then to look at every substring, the time complexity would be n squared. Okay, so and then also within the substring, we got to like count the number of vowels, so that is definitely unfeasible. So okay, that's fine. But again, let's go ahead and look at our test case Leetcode. So so here's like an idea which I have for you. So instead of counting the number of vowels in each substring, the basic idea, which can also be used for a lot of other counting problems, is so each particular vowel is counted by a certain amount of substrings. So what do I mean for this? So in our test case Leetcode, right? Let's look at this E in particular, this second E, I guess. And let's just go and write out the substrings which contain it. So, I mean, of course, we have E itself, we have ET, we have ETC, we have ETCO, ETCOD, we have ETCODE. We have EE, we have LEE, and we can have like sort of combinations of these top and the bottom ones. So for example, I could have like EETCO, just indent it a little bit so it lines up. But yeah, like the idea is that like, okay, which substrings actually contain this vowel E? Well, I can like basically keep track of my leftmost endpoint and my rightmost endpoint. So for example, like the left side of the substring could be as far left as L, and the right part of the substring could be as far right as ET as like this. So we have to choose like some left side and we have to choose some right side, and we can basically multiply those together and we can figure out like, okay, how many times is that vowel counted in our final answer? So again, like there's like a lot of substrings for this one. Yeah, maybe I'll make this test case a little bit smaller just for. Okay, let's just make it LETC. All right, so I mean, E is the only vowel, so that's the only one which you have to worry about. So we have, we can have the leftmost endpoint be this L, and then we'd have like LE, we'd have LET, we'd have LETC. We could have the leftmost endpoint be this E, and then we'd have like E, we'd have ET, and we'd have ETC. So our leftmost endpoint, we have like two choices, and our rightmost endpoint, we have three choices. So let me just write that down in particular. Leftmost endpoints, we have two choices, rightmost, three choices. And we notice that this is counted 6 times. So this E is counted, it's actually 2 times 3, or 6 times. And that's pretty much the idea. We like just go through this array and we figure out, okay, how many times is this vowel counted on the left and on the right? And here's one idea which you could notice. This 2 is related to the actual index of L, and this 3 is related to the distance from the endpoint. Okay, so how do we figure out the actual code in order to write? Let's go ahead and write out what these indices are. I think that could be pretty useful. So the indices are 0, 1, 2, and 3. So in particular, the number of possibilities for our left endpoint, if the index is I, it's going to be I plus 1. Okay, and let's just say that this last index is n minus 1. Okay, and we'll just basically use that to calculate the number of possibilities for our right endpoint. So our last index is n minus 1, and when e is equal to 1, there are 3 possibilities for the last endpoint. So for example, 3 minus 1 is equal to 2, so that's like not as that's like undercounting a little bit. So it turns out it's just n minus I. Okay, so I have n minus I for the right endpoint possibilities and I plus 1 for the left endpoint possibilities. So basically, I want to loop through the entire substring, and if I find a vowel, I'm going to add I plus 1 times n minus I to my answer. So let's hope that this is correct, and let's go ahead and code this. All right, I'm going to just keep track of some information for me. Like I'll just keep track of these values so I don't have to memorize them. All right, so my answer is 0. Okay, so I'm going to go through the character and the index so I can use enumerate. You don't have to use enumerate. You can just use a normal loop. But basically, if my character is a vowel, if my character is an A, E, I, O, U, then it's a vowel. Then to my answer, I'm going to add the product of these. Okay, and at the end, I'm going to return my answer. Oh, and n is not defined. N, as I said before, is the length of our word. All right, so this passes these test cases. Let's hope it's correct. And as we can see, it's correct, and it's a pretty fast solution as well.